Good day, everyone. This is Ms. Eljamin de Ocampo, a student from grade 12 Watt, and I am here to discuss the fifth part of the General Physics 2 of Math-2 series, the electricity, or mainly, as you can see, the Coulomb's law. By definition, it is the magnitude of the electrostatic force of attraction or repulsion between 2 point charges, which is directly proportional to the product of magnitudes of charges and inversely proportional to the square of the distance between them. So as you can see, by definition, or rather by formula, this is the very concise form of our own definition, wherein F is our own repulsive or attractive force, which is assimilated through Newton's. K is our own proportionality constant, or 9 times 10 raised to 9 n times m squared all over c squared. So Newton times meter squared all over c squared. R, or rather Q, would be our own magnitude of charges. It is usually the charges or the magnitudes that you will need to find, or that will be given in order to find our own F. And lastly will be our own R, which is the distance between charges. So if Q1 would be this one and Q2 would be this one, R would be this segment. So this would be our own R. So all of this law is beneficial in the long run, as it is also considered as the foundational formula to the next lessons to be tackled. Moreover, you can always find this formula throughout the course of this lesson. It will only revolve around F is equals to K times Q1, Q2 all over R squared. So if there would be any weird problem to be given, we can just derive certain formulas based from Coulomb's law. So with this is our own very first problem. What is the electrostatic force? So we are trying to find F. So I'm just trying to point that out right now. So what is the electrostatic force between the two pieces of grain in a grain elevator if one piece holds a charge of 5 times 10 to the negative 16 coulombs and the other holds a charge of 2 times 10 to the negative 16 coulombs while being separated by a distance of 0.06 meters? So for our own given, so first we have our own Q1, the magnitude of our own charge, the first charge, which is 5 times 10 to the negative 16 coulombs. Then our own Q2, which is 2 times 10 to the negative 16 coulombs. And then we also have a distance, so R, 0.06 meters. So for our own solution, first, let us go back to the very formula. So F is equals to, K Q1 Q2 all over R squared. So let me just zoom this in so we can have a lot more space to work with. So then we will need to substitute. So 9 times 10, F is equals to 9 times 10 raised to the 9th power times our own Q1 and our own Q2. So 5 times 10, negative 16 times 2 times 10 to negative 16. Then 0.06 squared. Then 9 times 10. So let us just simplify this further. So you can just input this to the calculator. However, for 6, for those that are slow in learning, then we will go step by step. So 5 times 10 to the negative 16 times 2 times 10 to the negative 16 would equate to 1 times 10 to the negative 31 all over 0.06 squared. So this would further equate to 9 times 10 to the to the 9 power, sorry. Then 2.77778. I am using 4 decimal points for more accuracy. Times 10 to negative 29, which would equate to our final answer, 2.5 times 10 to the negative 19 newtons. So this is our final answer for number 1. It is relatively simple as we are always just substituting our own given formula. So it is very important for us to know the formula that is given. So for our own second problem, we have two like and equal charges are at a distance of B is equals to 5 cm, or rather R is equals to 5 cm, and exert a force of F is equals to 9 times 10 to the negative 3 newtons on each other. So first we will have the given. As usual, so given. So we have R is equals to 5 cm, which we can further convert into meters because we are using newtons and the like. So we are not using the CGS, rather we are using the what we have at standard right now, so which is meters. So 0.05 meters. Next, we have our own F, or the attractive or repulsive force. So 9 times 10, negative 3, N. So what we are trying to find would be Q1 N, which is equal to Q2. So in the end, we are trying to find Q in general. So since two like and equal charges are at a distance, so it means that Q1 will always be equal to Q2 in this problem, which in that sense, we are trying to find Q in general, or the magnitude of Q. So for our own solution, our very first step, as always, would be on our own formulas. So F is equals to K, Q1, Q2 all over R squared. So as we might have seen, we have two like and equal charges. So meaning Q1, Q2 would only become Q squared because we have, once again, two like and equal charges. So let us properly solve this. First, we will need to derive the formula in order to find our own Q squared. So let us properly reiterate this. So F is equals to K Q squared all over R squared. So then we can just do this. F is equals to KQ squared all over R squared. Again, so this is basically the same thing since, as you can see, this would be 1. So when we multiply it further, it will only become KQ squared all over R squared, which would equate to, so we need to cross multiply again in order to get the formula. So we will have F R squared equals to K Q squared. However, what we do need is just the value of Q. So with this, we need to divide both sides with K in order for this to be cancelled. However, there is still a Q squared. There is still squared, which is not really an ideal situation when we are equating or finding a formula. So that is why we need to square root both sides. So with this, we have the final formula of Q is equals to square root of r squared f all over k. Again, very simple. So with this, we can just input the values. Let us input that value. So square root of 0.05 for our own, 0.5 squared times 9 times 10, negative 13. Sorry for my bad handwriting. It's very hard. 9 times 10 power of 9. So again, I can choose to actually do this step by step, but since we are running out of space here, let's just input this to the calculator freely. So all of this would equate to Q is equals to 5 times 10 to the negative 8. You can just freely input this to your own calculator and you would get the same thing. So this is our own Q. So since they are two like and equal charges, both Q1 and Q2 would be equated to 5 times 10 to the negative 8. And that is our own second problem. So for our own third problem, we have a very scary looking right triangle. So let us proceed. 3-point charges. Q1 is equals to 15 microcoulomb. So this, as you can see, this is what we call a mu. That is a mu. So that would equate to microcoulomb. Q2 is equals to negative 10 microcoulomb and Q3 is equals to 20 microcoulomb are placed at the corners of a right triangle as shown below. Find the net force on Q1. So first and foremost, we will need to tackle the given. So our own Q1 would be 15 microcoulomb. Q2 would be 10 microcoulomb. Why? Because Q1 and Q2 would only represent the magnitude of our own charges and not the direction of the charges. So as you can see, or as you might have recalled from our own formula or the definition of our own formulas, Q would only revolve around the magnitude, and magnitude does not have any negative. It does not have any absolute positives. Rather, it only has this. It is just an absolute number. So yes, Q3 would equate to 20 microcoulomb. Then we would have our own R1. R1 would be our own so R1 would be our own 5 cm. So this is Q1 going to Q2. Q2. Yeah. So this is our own R1. Then this is our own R2, which is Q2. Let me just input R1 real quick. And then R2, which is Q2 going to Q3. So this is 7 cm. This would further equate to, let me just put it here, really sorry. So R1 would equate to 0.05 m and our own R2 would equate, if you can still see it, 0.07 m. So it's basic conversion from our own R1, R2, and then our own magnitudes of our own charges. All of this would be beneficial in answering this very, very scary looking right triangle. Okay, so for our own solution. So as you can see, we have Q1 is going to Q2, which is our own R1, and Q2 is going to Q3, which is our own R2. However, what we do need is the net force on Q1. So Q2 to Q3 is not really beneficial in answering Q1, but it can indirectly lead us to finding Q1 going to Q3. How? As you can see, we have a right triangle and two given sides. So what do we need to find this side, or rather the hypotenuse of the triangle? And that is through the use of our own Pythagorean theorem. So c squared is equals to a squared plus b squared. So c squared would represent our own R3, or the Q1 going to Q3. So that would be c squared, a squared. A squared would revolve around our own Q1 would go into Q2, or our own R1. So 0.05 squared plus our own b squared, which is Q2 going to Q3, or 0.07 squared. 0.07 squared. Next, we would just need to simplify all of this. So this would equate to 2.5 times 10 to the negative 3 plus 4.9 times 10 to the negative 3 as well. So c squared is equals to 7.4 square root of 7.4 times 10 to the negative 3. So just square root both sides in order to get our own c, which is 0.09 meters. So this is our own c. So with this, we can now find Q1, or all of the net force on Q1. So meaning all of these. So with this, now that we have the value of this, which is Q3 is going to Q1, then we can have an equation now to answer the net force on the Q1. So with this, we have to make an equation of F net is equals to, always remember, F net is always the sum of the net force, or rather the force that is acting upon a certain object. So with this, we can just substitute that through the use of this. So K Q1 Q2 all over R squared plus K Q1 Q3 R squared. So we can probably simplify this further by allowing KQ1, which is the common factor within all of this, to be left outside while we parenthesize Q2 and the rest of the gamma. So KQ1, as they are the primary factor within this very equation, times Q2 R squared plus Q3 R squared. I forgot R1 and R3. Again, according to our own given, this is our own R1. Whoops, R1. This is our own R2. And this is our own R3. However, just deriving the equation is not done yet. We must know if our own Q2 or Q3 would be positive or negative. Why? Because this is very important in the sense that we are finding the net force on Q1. So as you can see, before anything else, as you can see in our own Q1 to Q2, as you can see from our own charge, it is in positive. So this is positive and this is in negative. So as we probably recollect different kinds of topics in physics, one particular topic on hand can actually greatly allow us to tackle the mystery, if you can say so myself, which is the law of charges. Again, what is the law of charges? Positive attracts negative. Or rather, dislike charges or unlike charges attracts like charges, like positive to positive, negative to negative, repels. So in this sense of Q1 to Q2, let me just erase this real quick. Whoops, I kind of erased it, but just go with it. So in the sense of Q1 to Q2, since this is positive, sorry about that, since this is positive and this is negative, what do you think will do? What do you think will happen? It would only attract themselves. So this only means that Q2 would go to the direction of Q1 because Q2 is attracted to Q1, just like a relationship, for example. So yes, so in this sense, since it is going up, going to Q1, then our own Q2 is positive. So it will still remain positive. But how about our own Q3? So, so this is Q1, so this is our own Q3. So since our own Q1 is positive, again, and our own Q3 is positive, what do you think? It would repel each other. So this only means that Q3 would move further away from Q1 because it has the same charges. And as our own Q3 is moving downwards, then that only means our own Q3 is negative in terms of our own Q1. So let us just change that into minus sign. And always remember from our own given, we will disregard any signs possible. We would only use the absolute value of our own charges because our own charges is the magnitude. So with this, we can just substitute. So with this, we can freely equate or substitute our own given formula with what was given. So 9 times 10 to raise to the 9th power. I think that's too big. Then 15 times 10 to the negative 6th power. Why times 10 to the negative 6th power and not micro? Well, if you convert this into our own decimal, it would only turn into this, times 10 to the negative 6th power. We cannot simply use this micro because what was given is the standards right now. We cannot really also input micro in our own calculator, so that is why we opt for this decision, times 10 to the negative 6th power. So moving on. So Q2, so we have 10 times 10 to the negative 6 all over 0.05 squared. Okay, this is gonna be hard, but 20 times 10 to the negative 6 all over 0.09 squared. So you can freely allow this to be inputted in your own calculator. So all of this would only equate to 206.67 Newton. And that is the Newton, or rather the force that is being exerted upon Q1 based from both Q2 and Q3.